Right, in my last video I showed how to use this angle grinder stand with the angle grinder to actually cut slots in a piece of steel to make expanding mandrels from the lathe. In that video I showed that this actual stand had some movement, side to side movement in the bracket here. I thought it might be wear, but it's not. It's just a bit poorly made. The rest of it is very good. The actual part that holds the angle grinder is nice and solid, and the actual base is cast iron. So I'm going to show you today how to improve this part here to make it more sturdy so that there's no side to side movement. So to disassemble it ready for upgrading, first remove this spring, pull it down with a pair of pliers and unhook it, and then take these two spindle housing covers off the top here, and this whole assembly comes off. And I thought I was going to be able to actually just knock these bushes through. They're plastic, the spindle goes through there like that, and that's very loose in that assembly. But I see they've got two bushes made of plastic, one either side, and I use a tool like this which I've made up out of stainless steel. It's quite sharp on the end there. This is a tool that I use for removing O-rings without damaging them. You can stick that in that or in between the bush in the housing there, and just hook that plastic bush out, and the one the other side. And you can see by the spindle in those bushes it's very loose fit, and they're not man enough anyway. The hole right through the assembly, when you put the spindle in there, is very loose, and that's why there's this problem with too much movement. And if you're just buying the cut-off table for its intended purpose, which is to cut off pieces of angle iron or box section steel to a certain length, it's just basically a cut-off table, this wouldn't matter at all. But because I'm using it for something more precision, I want nice long straight slots down a piece of steel. That's why I'm upgrading it. Otherwise there's no real need to do so. So when measuring the spindle there, it's about 394 thou. Lock my micrometer on that one, and I've zeroed my MPJ clock on that, and then putting that in the bore, you can see that the spindle is then about 30 thou undersized to the actual through bore. And I did notice that this hole here, it's only a cast hole, was wider one end, so it was badly tapered. So what I did was drill through from this side. This was the wider end. I put this on the bench drill nice and flat, and drilled right the way through with a 7/16 drill, which is 0.437.5 thou. So now I know that the actual bore is not tapered in any way, and I also know the exact size diameter to make the spindle. And it was just enough to clean up, just a light skim, so it hasn't weakened it in any way. So out of a piece of mild steel, I'm going to remake this one to a very close fit on that diameter in that bore, and then turn down each end to this size again, so that it locks up in the actual spindle housing assembly there. So that should cure that, and I'm going to replace the plastic bushes with ones I'm going to make out of brass. And for those that are new to machining, I'm using the DCMT 070204 insert type tool, with an ordinary coated insert. And if you're going to machine exceptionally hard materials, you want to use these. I've just bought this set from Banggood. It's the DCMT 070204 insert, but it's the blue nano type, and they're good for cast iron, very hard stainless steel, and even tool steels. They say that they actually last 5 times longer than the ordinary inserts, and I find that these are the best tips or best inserts I've actually used of this type. So at the moment I've got my 5-inch chuck back on the lathe, which is quite a heavy chuck, but that doesn't matter because I've got the heavy duty tapered roller bearings in the headstock, which I fitted some time ago. And because this is quite long and I didn't use a centre and the tailstock, I've got a couple of thou taper at this end. It looks to be the right size at this end, but it's a couple of thou bigger this end. So I use a quick method of getting that down without messing about too much. And after you've used a file method like that on various different jobs and got skilled at that with a bit of emery, you can actually take the taper out like that very easily without a lot of messing about. And now that one there is absolutely spot on end to end. And it's a absolutely lovely fit. So now I'm going to go and hacksaw that off in the vise, and then I'm going to bring it back and face off both ends and then turn each end to the same size as the original spindle, up to a shoulder, so that it actually fits in the spindle housing again. So to save time, I've faced off and turned down both ends the same diameter as the actual original spindle, and the actual spindle is a bit longer. That doesn't matter at all. This section here must go in between the two posts, and that one's a perfect fit. So now I've got a piece of 5/8 inch brass. It's a bit bigger than the actual diameter of the actual bushes, so I can actually turn that down to size in a minute. And I'm using a pilot drill first. I've centre drilled it, and I'm going to drill down to a certain depth, obviously for 2 bushes at once. The drill is smaller than the actual finished size of the bore, And if you're new to engineering, that's what you do, is use a smaller drill, and then when you drill down with the drill that you want to cut to size, it should cut to size. And that's particularly with drills that have been reground. They have a tendency of actually cutting over size. So now the 7/16 drill, which is the finished bore size that I want. And since I've converted this lathe over to belt drive, I've been watching the tachometer when I've been drilling, and drill as fast as I like. The torque is incredible and the spindle speed doesn't slow at all. And that's just right. I shall be putting that in with a bit of Loctite. It's a bit tighter one side than the other, but that's great. And I use a small HSS part-off tool for brass. And you can actually put the old bush on the side of that one and get it to the correct thickness in one go. And then just take the burr off there and deburr with one of these tools. You can get these on eBay or Banggood, I think. It just takes the sharp edge off inside there. And you can get all the spare blades for these. And before putting them into the housings, just check that the spindle actually goes through them. And that proves that the burr's been cleaned off nicely. And if you want to deburr them easier than I've just shown there with the hand, you can actually just lightly hold them in the drawer so you don't squash them at all. Put the deburring tool in there like that and just spin the chuck by hand, and that will put a nice little chamfer on the inside of the bore. So just put them in very lightly and just nip them up very lightly, like I say, without squashing them. You don't have to get them running dead true or anything. Just put the tool in like that and just turn the chuck by hand like that. And you can see that puts a nice little chamfer on there. And it's actually best not to use Loctite because you want to be able to test them first to see whether they go in there deep enough. That one's perfect, flush with the end face there. And this one this side, and I'm putting the deburred side into the bore, and then just checking that it's going to go down in between those two posts. If it didn't go down in between there, you'd obviously have to take one of the bushes out or see which one's too long and just skim it off on the lathe again. I don't think I'll put Loctite in those at all. They're a very good fit in the bore anyway. And then the spindle, there's a nice push fit in there. Back in the housing, and I'm not going to make up any actual clamps for this one because these plastic ones are quite sufficient, and I don't want to spend too much time on this. And there's no movement at all in that now, so it's a brilliant job done. There we go. It's absolutely solid. Yeah, I'm very pleased with that. So that's how to improve this cut-off table and make it into a really good piece of equipment. And it's only a very simple bit of machining to do so. Right, just before I go, I'd just like to show one or two new things that I'm doing. This is the 3-phase motor that I've just bought. It's 1 horsepower, and I'm hoping to use this on the Chinese mini lathe with the inverter when it comes. And this is the pulley mandrel which goes in the back of my lathe to convert it to belt drive. Now someone asked me, can I use drawbars still? And the answer is yes. I'm either going to make another pulley up quickly using the angle grinder to do the slots, so it'll be very quickly, or I'm going to make a 10mm to 8mm adapter here, so I can use the studding right through this existing one. That locks it up at the back the same. The mandrel doesn't expand, but it actually locks it rock solid in the back, and I can use ordinary tools like this with the drawbar just the same. So what I'm saying is the pulley mandrel can be used in both ways, either with the expander and lock nut at the back, or with the drawbar going right the way through it with a bush on the back and the lock nut. That draws it in nice and tight again, and you can use all these tools with drawbars just the same. And I've tested it out with another drawbar and it works perfectly. And just to show you a mock-up of that, I've taken the studding out with the cone from the actual pulley mandrel, and I've put a piece of 8mm studding right the way through the actual chuck. So now I can lock that one up. And it works perfectly the same. And I'm really pleased about that, because I've got many different chucks and things which I use on this lathe with drawbars, and I'm looking forward to getting the MT3 of this shank so I can actually use this tool on this lathe as well. And it didn't actually cross my mind actually when I was doing the conversion, and I didn't actually think about it until someone actually asked me about it. So now I'm really pleased that this has been proved to work perfectly. And one other thing, I showed this boring head being used on the Myford the other day. I got this one from Banggood, and this tool here, the 12mm insert tool, which I sawed off to a certain length so it goes in there nicely. I've just recently got these blue nano inserts for this one as well. And like I say, if you haven't tried these inserts, I really recommend that you do so. They're really tough tips or inserts, and they're great for all types of materials, like I said earlier.